Now, let's explore routing protocols. In study of routing algorithms, we made simplifying assumptions. We assumed all routers are the same, and we have a flat network of identical routers connected by links with costs. That is not true in reality. In the Internet's scale, we have billions of nodes and destinations. So a link state protocol cannot save all the path information in each of the routers in such a network. A distance vector algorithm might also never merge given the dynamics of such a complex network. On the other hand, we said that the Internet is a network of networks. ISPs may not want to give full access or full information of their networks to others, and each network administrator may want to work to control the routing within its domain. What should we do now? These problems could be addressed through organizing the routers to autonomous systems or domains. For each autonomous system that we will call from now on as AS, we can define the routing within the AS differently than the routing among ASs. We call the within the AS routing as intra-AS routing, and routing among ASs as inter-AS routing, and manage them in different ways. Within each AS, we define the routing protocol which runs only within that domain. We also determine the edge of the AS with gateway routers connecting this AS to other ASs. For inter-AS routing, we decide how those gateway routers communicate with each other. What are the defining factors when we decide about inter- and intra-AS routing protocols? We discuss them on three main defining factors: policy, scale, and performance. An administrator has full control over an AS. So when routing within an AS, the control is by the admin, and there is no need to include policies in the routing. However, in inter-AS routing, an admin of an AS needs to announce the decision factors such as who routes through this AS to the larger network. So inter-AS routing needs consideration of policies. Intra-AS routing is within a domain. It is usually fairly limited and within the capacity of current routers to have the information about the whole network. Inter-AS routing is within many different networks. It is not possible to have the full topology of the whole network. Putting the two together, it is possible to scale the design in a hierarchical way to have routing for a larger network and even the whole Internet. Within each AS, the focus of routing is on performance, providing the best experience for all the nodes in the same domain. Among ASs, though, policies for many reasons, like ownership, pricing, security, and similar considerations, play a more important role. The hierarchy introduced using the ASs also changes the nature of forwarding compared to a flat network. The forwarding table in a router that is within a network of interconnected ASs is affected by both of intra-AS and inter-AS routing algorithms. Intra-AS routing will determine entries for destinations within the AS, and inter-AS and intra-AS together determine the entries for external destinations. Suppose router 1A in AS1 receives a datagram destined outside of AS1. How the router 1A should forward the packet? The first step is to forward it to a gateway router. But AS1 has two gateway routers, 1C and 1B. Which gateway router should it forward the packet to? To be able to do this, AS1 must first learn the destinations that are reachable through AS2 and AS3. This is the job of inter-AS routing. This information should be propagated to all routers within the AS so that they know which gateway router they need to send a packet to.